go today, ladies and gentlemen. Welcome to Native Romeo High School. Hope you're doing well. Had a good weekend. Since the last time I saw you was Friday. I had to think about that for a second. Couple of notes and reminders of some things before we get started. Here's our objectives for today. I'm going to need to do these first three things with you, kind of review some stuff first, and then we're going to get into our homework assignment. You know, so there's two of them. We'll probably only get to one of them. We'll kind of see how the day goes and things like that. But the other part is that you need to make sure you understand and remember these notes that you need to bring in your 2 2-liter pop bottles to class by Friday. Okay? We're going to need them for Monday. Now, I'm only going to see you guys then on Thursday, which means the next time I'm going to see you is Monday of next week. We need to have them here on Monday because we're going to actually be cutting and making stuff on Monday with your pop bottles. So I'll be sending you out some reminders of those things. But keep bringing these things in. Okay, we need them here by Friday. The last thing then is, I had told you last week that there was going to be a quiz coming up on Thursday, and I've decided to cancel that one. We, with the iPad stuff and the rollout from last week and everything, we just didn't get through all the material that I wanted to get through. So I figured there was no sense in doing a quiz, not trying to cram everything in. So we're going to kind of go through the experimental design stuff today, but we won't have a quiz then. On Thursday, what I am hoping is that for the last half hour of class on Thursday, we're going to go outside to the Nature Center. And so you're going to need to dress appropriately. I would make sure that there's no flip-flops or open-toed shoes. Make sure you get a closed-toed shoe on, tennis shoes or something like that. Dress for the weather. If it's going to be a little cooler, bring a sweatshirt out, things like that. We'll leave from class here. We'll go out to the Nature Center. We'll come back then at the end of class then. So, pop bottles, no quiz, going outside on Thursday. We're going to be going outside on Monday, and we're going to be going outside on Wednesday of next week. Okay? So you got to dress appropriately for all of those things. Just a little heads up, and I will send you out another reminder of all that stuff. So today, what we need to be doing is we're going to be reviewing the Finding a Date, which we started on Friday of last week. We're going to go through a little bit of PowerPoint notes to kind of just highlight some more things and add some parts to that stuff. And then we're going to look at independent versus dependent variables, what they are, why they're important. And then we're going to get into our first assignment today, identify scenario number 1, which is looking at the experimental design process of an experiment. There we go. So let's do this first of all. Who are we looking to find a date for Friday? Who was it? Max. Did you find one yet? No yet. Okay. I was just checking. Just checking. Wanted to see if that actually happened yet. You still got time. Don't worry. All right. So let's do a quick review. What were the steps in the experimental design process? What's the first thing that we have to happen? What's the first thing that has to happen in the experimental design process? It is the observation. Thank you very much. Observation. After we make an observation of something that we don't know, don't understand, never seen before, what does that lead us to? Yeah, question or the problem? Very good. You can do it either or. Question, problem. We'll actually see on today's assignment that it's actually question/problem, which is really nice. From there, the most important step in the whole process is research. Now remember, more than likely your question could get answered in the research part, which means you're done. But if you haven't answered your question in the research part, we're going to continue on now. So after we've conducted our research, we're now ready to start solving the problem. But first of all, we need to create an hypothesis. H-Y-P, oh boy. Oh boy. H-Y-P-O-T-H-E-S-I-S. Hypothesis. Remember, and really all this is somewhat of an educated guess.
Wait, where's the other part of that Y?
It's right there.
Okay.
Really, your hypothesis is just an educated guess. It's what you think is going to happen, what you expect or predict to occur. After we've set up our hypothesis, what are we going to do? Set up the experiment. Now I've noticed that the same person is answering all of these questions. Now, either that means that this person is looking at maybe the answers, and or everybody else is just going to sit here like a bump on a log. Now, let's all participate. It makes things way more enjoyable for you and for me. Mostly for me, though. Okay? So, this is the part that we're going to add to in our PowerPoint. And so we're going to need to make sure that we get this part of this process down. There's a lot of things that we're going to add into the experiment to really understand how we set up a very well-defined, good, valid experiment. After you've conducted the experiment, what comes next? Analyze the results. A-N-A-L-Y-I-Z-E. Analyze the results / data. We're going to get practicing with this today as well. Now, in order, basically, when we get to this point, the way that we can actually analyze the results or the data is we need to graph it. So we're going to work on doing a little bit of graphing then today as well. The last part then, after we've actually set up our graph, we've analyzed our data, what do we need to do? Yes? Say that again?
Decide whether or not the hypothesis was correct.
And how do we do that? Through our conclusion. We'll determine then, through our conclusion, whether or not the data is supporting our hypothesis or not. And then subsequently, really the last step too in the process is repeat, repeat, repeat. You need to continue repeating the process to make sure that you're getting accurate data. Okay? So, questions about that? That seems like a real quick little review of it, right? Good. I can tell by the fact that you're already tired, that you're tired of me talking already. I need to do this a little bit quicker, and you need to help me go through this a little bit quicker so that we can get to the stuff that you need to be doing. What I'd like you to do next, go into Canvas, please. Go into the Nature of Science and find the PowerPoint from 98/99. It says 9899 PowerPoint. Open that up, put that into Notability then. That's where you're going to be taking some notes then on the PowerPoint that I've given. That it's actually the same PowerPoint, but it will just help you in the understanding of it then. Okay? Does anybody need help finding that? It should be the Nature of Science. Nature of Science 9899 PowerPoint. And then open that in Notability. During advisory, you need to go get that down. This one? No.
Couldn't stop laughing. Cassie told me. And he told me too. He started laughing again once I was like, how about that picture?
All right. Everybody ready? You've got it in Notability. 9899 PowerPoint. Open that up, put it in Notability. Make sure you get the notes set on that. Anybody else need help? Are we good? I can begin. You're going to need to take the. Do you have Notability? You have Notability. So these down here. All right. Here we go. Let's take a look at this part. Now, this is the actual PowerPoint that you've got. I'm just going to kind of go through and I'll highlight some of the parts that you're going to need there. Love this beginning line. Research this to see what everyone else has seen and to think what no one else has thought. Because really, again, in the order of doing your research, if you can't find the answer, you're the thinking that no one else has thought. You're that last part of that sentence, which is the best part about it, right? Your original thought. Okay? As you go through this then, don't want that. Don't want that. How this is going to work. Nope. All right.
It's your arrow thingy.
Thank you. There we go. Experimental design then, so as we go through this. So I'm going to go through this a little bit quicker and we'll stop at some parts then. Observations, again, we're going to see something that we don't know. We're going to see something that we don't know, which prompts us to then ask a question. Why do leaves change color? Right? Are they changing color? Now I do a little research, and I'm either going to find the answer or I'm not going to find the answer. And again, that was the whole core. If you find the answer, you're done. If you don't, that's the original thought now. That's the brand new things. Hypothesis then from our research will lead us to a hypothesis, remember. And all that is an educated guess. It's what we think is going to happen in the process. We should really try to stay away from the I statements. I think or I believe that. Let's try to stay away from those things. And actually, let's just make your hypothesis be a sentence. The greater caffeine consumption in humans, the faster the heart rate. Leaves change color based upon daylight. Boom. There's a hypothesis. Okay? From that, now this is where we're going to need to start taking a little bit more notes in. It's about the experiment. In our experiment, our hypothesis leads us to then design an experiment. And in particular, the experiment needs to be repeatable. This is a really important concept of repeatability for two different reasons. One, because you need to be able to repeat the experiment over and over to see if whether or not you're getting the same results. And if you are, then you know you're doing the experiment correct. The other part of the repeatability comes into where science is what we call peer review, which means another scientist is reviewing your work. What they'll do is they'll go through and perform your experiment. If they can repeat it and get the same results, it's valid then. It's true, it's accurate, it's right, it works. And so that's why this whole process needs to be repeatable. In particular, the repeatability part comes in with your procedures. I do this first, step 1, step 2, step 3, step 4. It seems tedious. It's not. Because that's the part when you keep things in an orderly fashion, that you've organized and written it down, that's how the experiment can become repeatable. So when we look at any good experiment, we have to have a couple different things to it. One is we have a control group. The other one is we have an experimental group then. The control group is where all the variables, now variables is basically a fancy word for something that you change. A variable is a change. So in a control group, there are no changes. And the way that I kind of think about a variable, or the control group, is what we compare the results back to. So when you're all done and you've collected your data in your experiment, you need to then compare the data back to your control group. What you know will occur. What you know will happen. It's the answers. Now your experimental group, it's the thing that you're changing. It's you change one part of it. And so there's one thing that changes, and only one. Only one change. If you have more than one change, you're not sure then what is actually affecting the outcome. Is it this or is it that? And if you've only got one change, you know that it can only be this that's affecting the outcome or the change to the experiment. Pardon me, my phone is ringing. Hello, Mr. Austin. Heather. Yes. She has and I didn't write her path, I want her coming down every day. She's doing like an independent study type of thing. Maybe what I can do is just write up a pass every day for her. But she's coming in to do work. And if she's not, then you can send her back. Thanks. All right. So, in the experimental group, we're going to kind of get into a little bit more about what does that mean and things like that. But we've got then a control group and an experimental group. From there, erase. I need to write some more things on here. This is now about when we gather our data in our experiment. There's two different types of data. This is kind of the really meat and potatoes of the stuff. This is the important part. When we collect data, there's two different types of data that we can collect. Quantitative data and qualitative data. This is the easiest way that I can think about these to help you understand them. Quantitative data looks at numbers. And it's numbers that you are recording or measuring. So this would be things like height, weight, temperature. What's another good one? Height, weight, mass, right? All of those things. Any quantity that you are measuring and have to record that's a number would be quantitative data. The other one is qualitative data. And qualitative data are words. And these are words that you use to describe something. Color, texture, smell, appearance, rough, smooth, would all be then qualitative data. It's so that you are describing what's taking place or what has happened in that process then. Hopefully when you conduct an experiment, you're able to get both quantitative data along with qualitative data. You should be able to find both in a really good experiment. There are some instances where you'll have more quantitative than you will have qualitative. In another example that we're actually going to be doing next week with our bottles, the experiment that we're going to be setting up, we actually really probably won't have any quantitative data. We will have all qualitative data. So again, what's the outcome, what we're looking to get for, and what's the best way in order to measure that? It's through these two types of data then. Numbers or words. So, questions so far? Is all this somewhat making sense? Seems to flow pretty well, right? Okay. Next part then. So we look at quantitative data. Remember, our numbers. Quantitative data. We've got two different types. And this is the most important concept, and it's also the hardest concept in order to grasp. And this is the one that we're going to spend a little bit more time reviewing, is this idea of independent and dependent variable. And I'm going to actually write these down here on the board, and we're going to leave them up there so that you can use them through the course then of the day, because it will really help you as far as being able to answer some questions. But they're also the hardest ones to understand and get. Now, we have the independent variable. It's on the x-axis. It's not changed by other variables, and it's what you can control and manipulate. Let's put that in a little bit different term then so we can all see that one. Independent variable. The way that I think of the independent variable, it is what you control / change in the experiment. The independent variable is always going to be found on the x-axis. Now, the dependent variable if the independent is the thing that you're changing, the dependent variable is the outcome / results of the change. It's basically going to be what you measure. And the dependent variable always will be found on the y-axis. So remember, if you're going to set up a graph, and this is one of the things that we're going to be doing today, you have got your x-axis and your y-axis. So you have your independent variable on the bottom, you have your dependent variable on the side, and that's how you will then graph the data that we're collecting. And so we're going to kind of go through these two examples in a little bit more depth then, with some different examples that we're going to look at, our independent versus dependent variables then. But again, the independent is the thing that we control, it's the thing that we change. Let's say it would be, if we're going to be looking at laundry detergent and how clean clothes get. The laundry detergent would be the independent variable, it's what we are changing, and the outcome, or what we're measuring then, is how clean the clothes become. So, detergent, clean. How clean they are would be the dependent variable, what we are measuring. All right? And again, we'll go through more examples of that in a little bit. Now, if you think that you need more data to draw more conclusions, do the experiment again and again. Keep repeating the process. And finally then, after we've analyzed our results, we need to form conclusions then. Does the data support or reject our hypothesis? What is the answer to your question? And last but certainly not least, during your conclusion, is we need to be accounting for these experimental errors. What went wrong during the experiment which had an outcome or affected the results of the experiment? It's not bad to have experimental errors. This is one of the things that we tend to think about, is we always think of errors as bad. It's not bad to have errors. It's actually just bad to not state what the errors are. You actually need to state what the errors are and how they affected the outcome. Then when you repeat the process, you change and you account for your experimental errors to see how then your results are different. So, this conclusion part, again, is a really important part of the whole process. Now, from there, we can repeat it many times. We've collected our data to see whether or not we've got the right things. Does it answer our hypothesis? Did we expect to happen what we thought was going to happen? Is during our analysis and our conclusion. Now, I've put a couple of resources into Canvas for you, as far as there's some videos that you can watch about independent, dependent variables, graphing, and also to the experimental design process. If you need to have some brush ups, some refreshers, you can go to those Canvas places and find those things. Okay? What I would like for you to do next is this. Go back into Canvas and find the, I believe it's called 9899 Simpsons. 9899 Simpsons variables. And it will look something like this. When you pull that up, go ahead and put that into Notability then, so that you can do this then. Now, The Simpsons, I love this little thing. It's a really simple, but I think super effective exercise as far as being able to determine independent and dependent variables in particular. The other thing it does too is it talks about how do we change an experiment around. I only really need about 10 more minutes of time, and then I'm going to be done. I'm going to let you get going on some things. My first question to you is this. This is what I call your fist of 5, 0 through 5. 0 through 5 is, tell me what is your current comfort level with this whole idea of independent and dependent variable, that you can be able to identify what those are just from what we've learned so far. So 0 means I have no clue what you're talking about, Mr. Austin. You're speaking German. And 5 is, sit down, Mr. Austin, I can do this. Okay? Where are you at in this process, 0 through 5? And be honest. Because again, if you're not honest with me, it's better, only way I can help you become better at this process. Okay? So, as I'm looking around the room, I'm seeing some good things. Wonderful. Now, remember your number because my job is to hopefully change your number at the end of this. Okay? So let's put this into application and see how this works. We're going to look at this from a very simple process, looking at Mr. Smithers with the Simpsons. Now, Mr. Smithers, let's just read this, thinks that a special juice will increase the productivity of his workers. He creates 2 groups, 50 workers each, and assigns each group the same task. In this case, they're stapling a set of papers. Group A is given the special juice to drink while they work, and Group B is not given the special juice. After 1 hour, Smithers counts how many stacks of papers each group made. Group A that got the juice made 1,587 stacks. Group B that did not get the juice made 2,113 stacks. Now, let's go through and identify these things then. And again, these are all parts of the experimental design process, so we can kind of put this into some application now. What is Mr. Smithers' control group going to be? What did he compare the results back to? What group did not get changed? Group B. You can write that in there. I will do the first one together, and then you're going to do the next 4. The independent variable, what was the thing that Smithers changed in the experiment? The juice. Thank you very much. The dependent variable, the outcome of the change, the results of that is the productivity. Thank you very much. I can just think it as the number of stacks. That the number of stacks changed whether or not they got the juice or not. And there's a really kind of, and this is, it might make sense to you and it might not, but one way that you can say this is the juice dependent upon the number of stacks, or is the number of stacks the productivity dependent upon the juice? And so when you say that the number of stacks is dependent upon the juice, the number of stacks is dependent upon the independent variable. It's an easy way to kind of go through and just say it to your mind. Does this make sense? Because one way it does, the other way it doesn't. What should Smithers' conclusion be? Did the juice help increase the productivity of the workers? No. Not help. Okay? Step 5, this is the most important part now. And this is where I need for you to really think. How could the experiment be improved? What could Smithers do to change the experiment? To get different results. Change the juice. Thank you very much. What's another one? Changing the task. And I love that you're saying that. Ideally, the task shouldn't make any difference. And because basically, Smithers wants them to do this task, right? That's what he wants them to do. So seeing whether or not the juice affects that is fine. We don't want to change the task. But I'm glad that you said that. What else?
You can change the amount of juice.
Change the amount of juice. Thank you very much. What else?
Give the other guys fake juice.
Sure. We could give Group A, right, or Group B, the control group, we could give them some type of placebo. Maybe water, right? Make them think that they're drinking a juice. Fine, love it. Ideally, it shouldn't make any change to it, but it could. What else could we change?
Who's doing it?
You know, and someone says it every hour. I'm glad that you guys do. Somebody like switching groups, right? I really don't want to switch groups. Here's the reason why. Once you've got a group established as your control group and your experimental group, we don't want to change them around. The reason being is this: we don't know when the effects of the juice are going to wear off. Does that make sense? I know in our minds it's going, it's just juice, it doesn't make any difference. But it does taint the experiment, because if you change groups, does then the control group, if they outperform the other group, they then still have the juice the first time? Does that make sense? And you don't know whether or not, if they outperform it, is it because they had the juice the last time? So we don't want to change the groups. We want to keep the groups the same. We want to keep the task the same. What else can we change? The awkward silence gets awkward, doesn't it? I'm not going to come to your rescue. Think of something else. What else can Smithers change? Read. In particular, right here. What else can we change?
The time.
The time. That's a great one. Smithers tested after an hour. Maybe what happened was Group A that got the juice went out to an early lead in the first half hour and then crashed the last half hour. So maybe if Smithers came back after the first half hour, Group A would be outperforming Group B, right? You don't know. So changing the time could. Changing how much they're drinking. Change the time of day. See what we're doing? You could do a lot of different things then to change this process around to determine whether or not it's still the juice that's affecting the results. Okay? This is part of the conclusion. And one of the things I told you on Friday last week, the conclusion is the hardest part. When you have to go through and do an experiment, everything is actually really easy until you get to the conclusion. The conclusion is really the only part that you have to turn your brain on for. Everything else is kind of just on auto cruise, autopilot. You can make it through it. Until you get to the conclusion, then you're like, okay, turn on brain, it's time to think. And that's when you really need to sit down and start looking at what's going on and thinking all the possibilities. Okay? So, what I'd like for you to do is this. I'd like for you to take 10 minutes, and I'd like for you to do Homer, Bart, Krusty. Do the next 3 in 10 minutes time. If you need a little more time, we will. Okay?